Hey everyone, welcome to another deep dive. Looks like we're taking a closer look at how AI models learn today.
Specifically, those two techniques you were curious about.
Yeah, SFT and RL.
Right, supervised fine-tuning and reinforcement learning.
You bet. We got some really interesting research to dig into, all thanks to you. So,
Just be fun.
yeah. So to kind of set the stage
Yeah.
for anyone just tuning in,
Right.
SFT, it's basically like showing the model a ton of examples and say,
This is the right answer. This is the right answer. Like flashcards almost.
exactly, like drilling multiplication tables.
Yeah, just to get it up to speed quickly.
Right. And I can see how that'd be super effective for
Yeah, for like getting it to follow instructions or, making sure the text is formatted in a specific way.
exactly.
But it kind of runs into a problem
When
when
it encounters some
when
problem.
it encounters something new, right? Because if you only ever learned math by memorizing flashcards and then you got a word problem,
You'd be like, whoa, what?
yeah, you wouldn't know what to do with it. So that's where RL comes in.
Ooh. Okay, so how does RL kind of address that?
Well, RL is more about trial and error. So it's like, think of it like learning to ride a bike.
Oh, okay.
You don't just read the manual and hop on and,
And you're good to go.
yeah, you're going to wobble. You might fall a few times.
Totally.
But you figure it out through practice and feedback. And that's basically what RL is doing.
So it's more intuitive. It's more
Right.
like how humans learn.
More human-like, absolutely.
Cool. Okay, so how did the researchers test these two approaches?
Well, they came up with some really cool experiments to see how SFT and RL would do when
Things changed up a bit.
the rules of the game kind of changed mid-game.
Game. Ooh, sneaky.
Yeah, and one of the experiments they did involved a card game called General Points.
Okay, a card game, huh?
A card game.
I'm already intrigued.
So imagine you have 4 cards,
Okay.
and you have to use those 4 cards to create an equation that equals 24.
Oh, my brain hurts already.
You can use addition, subtraction, multiplication, division,
Okay.
parentheses, all that.
So like order of operations too.
Yeah, exactly.
Oh, man.
But here's the twist.
Okay.
They decided to change how the face cards,
Yeah, try queen.
Jack, Queen, King, exactly.
Now-
Sometimes the Jack will be worth 11, other times it would be 10.
Oh, that's so devious.
Yeah.
Like even I, as a human,
Yeah.
I'd be thrown off by that.
It would throw you off, for sure.
So how did the AI models handle that?
Well, the SFT model struggled.
Oh, so it couldn't adapt.
It couldn't really adapt. It was too stuck on those memorized combinations. It's
Okay.
like, wait a minute, this isn't what I studied.
Yeah.
But the RL model,
Oh, really?
yeah, the RL model was able to adapt to those rule changes.
So it was actually like learning the underlying concept.
That's right. It was figuring out the principles of the game.
Wow.
Yeah,
Okay, so it wasn't just winning, it was understanding.
exactly. It was understanding.
Cool. So what else did they do to kind of test this?
Well, they wanted to see how these models did with a more visual task.
Okay.
So they moved on to VIRL, which is,
What is that?
it's this environment that's designed to test an AI's ability to navigate a city.
Whoa, hold on. We're going from card games to navigating cities.
That's right.
This is amazing.
So basically, imagine you're in a new city.
Okay.
You have written directions
Yeah.
and some snapshots of street views.
Okay.
That's all you get.
So that's what the AI is working with.
Yeah, that's all the AI gets.
Wow.
And it has to figure out how to get where it needs to go.
That's tough.
Yeah, even for a human, that would be challenging.
For sure. So they're really testing its ability to interpret
Yes,
like directions and visual information.
exactly. Spatial reasoning.
Right. Spatial reasoning. I like that.
So they tested 2 ways of giving directions.
Oh, okay.
One was absolute directions.
Like north, south, east, west.
Exactly.
Right.
And the other was relative directions.
Like left, right.
left, right, left,
Yeah.
right, slightly left, slightly right, that kind of thing.
Okay. So more
nuanced.
More nuanced directions.
Yeah, so they trained the AI on the absolute directions.
Okay. But during the test, they switched it up.
Oh, they did?
Yeah, they gave it the relative direction
So sneaky. To see if it could adapt.
to see if it could translate its knowledge into
Yeah.
this new system.
Okay, so could it?
Oh, well.
How'd it do?
The RL model did great.
Oh, wow. Even though it wasn't trained on those relative directions?
Yeah, it was able to adapt.
So it's showing true spatial reasoning then.
It really is.
Wow.
The SFT model, on the other hand,
Oh, no.
got lost.
They got lost. Oh, no.
Yeah, couldn't quite make the jump.
So again, it's showing that the RL model can actually
Learn the principles.
learn the underlying principle.
Now just memorize.
And not just memorize exactly. This
Yeah.
is so cool. But it gets even more interesting.
Oh, yeah.
Yeah. They noticed something unexpected about the RL model and the card game.
Okay, I'm all ears.
Yeah.
What is it? So it seems like the RL model actually got better at recognizing the cards just by learning to play the game.
Hold on. Like, its visual recognition skills improved?
Just by playing the card game. How is that even possible?
So to test this, they set it up so that the AI had to correctly identify each card before it could even try to solve the equation.
Oh, so like an extra layer of challenge.
Exactly.
Really?
And what they found was that the RL model was way better at recognizing the cards compared to the SFT model.
Wow. So it wasn't just learning the rules, it was picking up on those visual cues too.
Yeah, like tiny details that helped it figure things out.
That's wild.
Yeah.
Okay, so if RL is so good at adapting and learning, do we even need SFT?
Well, that's a good question.
Like, can we just skip right to the RL training?
Well, they actually tried that.
Oh, they did.
Yeah, and it didn't really work.
Really?
Yeah,
I'm picturing the AI just like staring at the cards, like, what am I supposed to do?
pretty much.
So SFT is still important then?
Yeah, it seems like SFT is really important for laying the groundwork.
Okay.
Like it gives the AI the basic understanding of the task, the language, the structure,
Okay.
and then RL can build on that.
So it's like they work together.
It's like a team effort.
I like that. Okay,
Yeah.
so we've got these two training methods working together to create these really impressive AI models.
Yeah.
But what does this all mean, like, for the future of AI?
Well, that's what's so exciting.
Yeah.
The fact that RL can figure out the rules in a card game and then also navigate a city that suggests a level of learning that goes way beyond just memorizing stuff.
Right. It's like it's actually understanding.
Just getting at something deeper.
Deeper.
Yeah. And that opens up a whole world of possibilities.
Like, what kind of real world problems could we solve with this type of AI?
Oh man, the potential is huge.
Yeah.
Think about personalized medicine, like treatments that adapt to each patient,
Oh, wow.
or robots that can navigate like disaster areas or even other planets.
That's incredible. Like, we're not just programming AI anymore, we're teaching it how to learn.
Exactly.
Wow. Okay, but before we get too carried away, let's go back to the verification part.
Right, the verifier.
Yeah. What exactly is that and why is it important?
So the verifier is kind of like a coach. It's evaluating the AI's performance, giving feedback, providing guidance.
Got it. So it's helping the AI learn and improve.
Exactly.
Okay. And the researchers found that more verification steps during RL training led to even better generalization.
Right, it's like having a coach who's constantly giving you feedback.
Oh, I see. So the more feedback, the better.
Seems that way. Yeah, the RL model really benefits from that extra guidance.
Makes sense. So could we take this even further?
How do you mean?
Like, could we incorporate human feedback into the training process?
That's actually a really interesting area of research.
It is.
Yeah, imagine combining the power of RL with the insights of human experts.
Whoa, that could lead to some seriously amazing AI.
AI that's more aligned with human values and goals.
I like where this is going. This whole conversation has been mind-blowing.
It has.
We've gone from card games to city navigation to personalized medicine and robots on other planets.
It's pretty amazing what AI can do.
It really is. But even with all these advancements, it's humbling to think about how much we still don't know about how AI learns.
Yeah, we're still just scratching the surface.
So what are some of the big questions that researchers are working on now?
What are the next frontiers? Well, one of the big ones is figuring out how to make RL algorithms more efficient.
Okay, more efficient, like less computationally expensive.
Exactly, because right now they can be pretty demanding.
Yeah, that makes sense. Like if you're trying to run a complex simulation on an old computer, it's going to take forever.
Exactly. So researchers are trying to find ways to streamline the process.
So we can use it for more things.
Right. And another really interesting area is finding ways to give AI models more sophisticated knowledge.
Oh, so instead of just feeding it data, we give it some kind of like background information.
Yeah, like common sense reasoning or even ethical principles.
Wow, so it's not just learning from data, it's actually understanding.
It's getting closer to that, yeah.
That's amazing. It sounds like we're moving towards AI that can really think for itself.
Well, that's the goal.
A lofty goal.
It is. But the research you shared today, it shows that we're making progress.
Yeah. This has been a wild ride. We've covered so much.
We have from SFT and RL to personalized medicine and robots on other planets.
It's mind-blowing to think about what AI is capable of.
It really is.
So as we wrap up, what's the one thing you want our listener to take away from all of this?
I think the key takeaway is that AI is changing rapidly.
Yeah.
We're moving away from just programming AI and towards AI that can learn and adapt on its own.
And SFT and RL are leading the way.
AR, they're opening up all these incredible possibilities.
Possibilities that could change the world.
Absolutely.
Well said. That's a perfect note to end on.
It is.
We've learned so much about the potential of AI learning And it seems like there's still so much more to discover.
Oh, yeah, we're just getting started.
So to our listener out there, keep exploring, keep learning, and keep wondering.
And keep sharing your research with us. We love diving into this stuff.
That's right. Thanks for joining us on this deep dive.
It's been a pleasure.
See you next time.